Alright, greatest prime I would need to consider to test if 222 is prime. Well, I'm going to start with looking at the square root of that. So I get about 14.89. Okay, so what I need to know is what's the largest prime smaller than 14.89, and that would be 13. So as far as testing prime numbers go, I only have to test up till 13 to see if it goes in there, because then I would have found everything else up to that point. So the answer is 13. Alright, next up is the Euclidean algorithm. Okay, so this involves the dividing and looking at the remainder to determine the GCD of a set of numbers. Okay, so I want to take 1,234 into 26,354. Okay, so I'm going to type that in a calculator. Alright, so I get that it goes in there 21 times with a remainder of, and so that's where I want to, I'll kind of show that. Okay, so this is where I want to take 26,354 minus 1, 2, 3, 4 times the 21. Alright, and that gives me a remainder of 440. Okay, so then I want to take 440 into 1,234. Alright, and I get 2 with a remainder of something. Okay, so that gives me a remainder of 354. And we're getting closer. Alright, so then 354 goes into 440. Well, I can see that it goes in there once with a remainder of 6. Then I want to go 6 into 354. And I get 59 with a remainder of 0. Okay, so right when that 0 comes up, the number that was my last remainder is the GCD. Okay, I'm sorry, Mr. Soleil is going to correct himself. He made a mistake, and I'm sure some of you have been screaming, and I just completely ignored you. Sorry about that. Right back here. My math was not as good as I had hoped. Sorry about that. Okay, so let's go revisit this again. It's not too bad a misstep there. 354 does go into 440 once. The remainder is a little bit bigger than what I wrote. It's actually 86. Alright. So now 86 is going to go into 354. Let's see. So it goes in there 4 times. And I need a remainder, so 354 minus 86 times 4, I get 10. So we'll move this over here. So 10 goes into 86. That would be 8 times with a remainder of 6. And 6 goes into 10. 1 time with a remainder of 4. And 4 goes into 6 one time with a remainder of 2. And 2 goes into 4 twice with a remainder of 0. Okay, so the 0 is a good indicator I'm done. And my GCD would be the last remainder that we used. Okay, so GCD in this case is 2, which is much better than the other answer I had. Sorry about that. Alright, least common multiple of 4, 14, and 15. So what I'm going to do is I'm going to make a list of the prime factors for each of those numbers, and then we'll combine them to get the LCM. So that would be 4 would be 2 squared, 14 is 2 times 7, and 15 is 3 times 5. Okay, so the LCM should have in it, should have at least 2 2's, so 2 squared, should have a 3, a 5, and a 7. That's basically how that works. I just got all of that. Okay, so, and that's actually fine if you do want to type it in. So what, 4 times 3 times 5 times 7, so 420. However, the prime factorization is what I'm really going to give you credit for, but I don't mind if you want to multiply it out and actually get a number that you feel better with, I guess. The product of two numbers is 6,648. Their LCM is 1,612. Find the GCD. Okay, there's actually a formula here. Okay, so the formula that I'm hoping you'll use, not hoping you'll use, the formula that you need to reference in this is if I have two numbers and I multiply them, that's the same as multiplying the GCD of the two numbers times the LCM of the two numbers. Okay, so if I know the product, in this case is 6,448, and I'm trying to find the GCD, I know the LCM happens to be 1,612, so I kind of have this formula that I can use to set up. So what I want to do is I just want to divide. So the GCD in this case is, when I divide 6,448 by 1,612, so I happen to get 4. So GCD is 4. Alright, last but not least, use division of primes method to find the LCM of 15, 81, and 3,465. Okay, so what I'm going to do is I'm going to build a little chart. 15, 81, 3,465. Okay, and then I'm going to divide by the smallest prime number that will go into all three of them. Obviously, we're going to start with 3. And so when I divide, my numbers are going to change. Let's see, so 15 goes into 3 5 times. 81 divided by 3 is 27. 3,465 gives me 11,055. Alright, I still see that I can take another 3 out of one of the numbers at least. So the 5 I just dropped down, 27 becomes a 9, that becomes a 385, and I still see that I can take out another 3. And let's see, can I take out a 3? I can't take a 3 out of that, so and I'll do one more. So 5, 1, and then 385. Okay. And then I'm going to take out the next prime, which is 5. So that goes in there once. That's 1. 385 divided by 5 happens to be 77. And so I'll take out 7, and I'll take out an 11. Okay, now this list, that row of numbers, is my LCM. So that would be, what, 1, 2, 3, 4. So 3 to the 4th times 5 times 7 times 11. And again, that's perfectly fine. You can leave it like that. If you happen to be compelled to find the exact number, 31,185. But it's this chart that I'm looking for on this.